Math Blast 21, Order of Operations. Here, we're given expressions that we need to simplify using the order of operations. So, parentheses are done first, followed by exponents, and then multiplication and division is done together from left to right. And addition and subtraction is last from left to right. So here, in this expression, I see that I have parentheses, 2 plus 9. I will simplify that, bring all other numbers and operations that I have not accounted for yet down, and so now I have a new simplified expression. There are no exponents, so I'm now at the step multiplication and division. Again, together from left to right is what we have to remember. So 6 times 11 divided by 3. 6 times 11 is 66, divided by 3 is 22. I will bring down all numbers and operations that have not yet been accounted for and move to the next step. Addition and subtraction together from left to right. So 32 plus 22 is 54 minus 12. When I take 12 from 54, I'm left with 42. So the simplified version of this expression is 42. Here, let's start from the beginning. Parentheses is the first step in my order of operations. 1 plus 3 is 4. I will bring down all other numbers and operation symbols that I have not yet accounted for, and I will move to the next step, exponents. There are none here, so I'm moving to multiplication and division. From left to right, I have multiplication here, here, and here. So let's simplify. 10 times 4 is 40, 2 times 4 is 8, and 2 times 5 is 10. Bring down any other numbers and operation symbols that have not yet been accounted for and move to the next step. We are now at addition and subtraction. Together from left to right, 40 minus 8 is 32. Take 10 away from that, and we have 22 as the simplified version of this expression. Adding and subtracting fractions. 9 2/5 minus 5. Here, I have 9 whole and 2/5 of another whole, and I want to subtract 5 whole and no fractional part. So when I subtract, I'm going to look at my fractional parts here. I'm not taking any fractional part away from 2/5, so I'll still have 2/5. And I'm taking 5 whole away from 9 whole, so I have 4 whole. So the difference is 4 and 2/5. Here I have 2 and 5/8 plus 3 and 5/6. So I'm going to add them, but I know, using math here, that I cannot add fractions that have unlike denominators. So I'm going to change my fraction denominators to an equivalent fraction with common denominators. I still have 2 whole, and I still have 3 whole here. But I'm going to change my 8ths and 6ths to both be 24ths. I know I can multiply 5/8 by a form of 1, 3 over 3, which is 15 24ths. And I can multiply my 5/6 by a form of 1, 4 over 4, is 20 24ths. And now I can add. I have 15 24ths and 20 24ths, which is 35 24ths. And 2 whole plus 3 whole is 5 wholes. Now 5 and 35 24ths, I notice, includes an improper fraction here. I have more parts than are in 1 whole. So that's the same as 5 plus 35 divided by 24. 24 can go into 35 one time, and there's 11 left over. 11 24ths left over. So 5 whole plus the 1 and 11/24 is 6 and 11/24. Interpreting a fraction as division. Fill in the blank to make the statement true. 6/7 is the same as 6 divided by 7. Keep in mind that a fraction can be looked at as a division problem. A teacher has 160 pieces of candy. There are 20 students in the class, 13 of which are girls. What division problem could be used to find how many pieces of candy each student will get? Rewrite the division problem as a fraction. Okay, so we're trying to figure out how many pieces of candy each student will get. So since there's 160 pieces of candy, we want to take those 160 pieces and divide them or equally share them among 20 students. We're not worried that 13 of them are girls. The question is asking about each student. And that, we know, is the same as 160 divided by 20. Shape attributes. Complete the hierarchy and identify each shape by circling each name that applies. Then tell which is the most specific name and why. So let's fill in the hierarchy here, starting off with quadrilateral. That's our four-sided figures. Any four-sided polygon would be a quadrilateral. Then comes the trapezoid. That would be a quadrilateral that has at least one set of parallel sides, followed by a parallelogram, a quadrilateral that has two pairs of parallel sides. Next comes a rectangle and a rhombus. Rectangles are quadrilaterals that have 4 right angles, while rhombus would be a quadrilateral that has 4 equal sides. Now, if the quadrilateral is a rectangle and a rhombus, then it is a square. Squares are quadrilaterals with 4 right angles and 4 equal sides. So we can use our hierarchy here to help us figure out what shape 1 is. Shape 1 is definitely a quadrilateral, 4 sides. It's a trapezoid. It has at least one pair of parallel sides. It is a parallelogram because not only does it have this one pair, but 2 pairs of parallel sides. It is not a rectangle. It does not have 4 right angles. I see 2 obtuse and 2 acute angles. It is not a rhombus. It does not have 4 equal sides. Therefore, it can't be a square. If it's not a rectangle and a rhombus, then it's not a square. So most specifically, this shape is, shape 1, we're going to say is a parallelogram. Because it's a quadrilateral with 2 pairs of parallel sides. Let's look at shape 2. Shape 2 is a quadrilateral. It has 4 sides. It's a trapezoid. It has at least one pair of parallel sides. But notice, again, not only does it have just that one pair, but it has another pair, 2 pairs of parallel sides. So it is going to be a parallelogram as well. It has 4 right angles. So shape 2 is also considered a rectangle. It does not have 4 equal sides, so it's not a rhombus. And if it's not a rectangle and a rhombus, it can't be a square. So most specifically, shape 2 is a rectangle because it's a quadrilateral with 4 equal sides. With 4 right angles. There we go. Rounding. We're going to use a vertical number line to round here. We're rounding our given number to the nearest hundreds place to start with. So I'm going to look at my number and figure out how many hundreds. Let's review place value here. To the right of the decimal, I have the tenths, hundredths, thousandths. To the left of the decimal, I have the ones, tens, hundreds, thousands. Since I'm going to round to the nearest hundreds, I want to figure out how many hundreds make up my number. So going all the way to the hundreds place, this number is made of 45 hundreds, which is written as 4,500. If I add 100 to that, I would be at 46 hundreds, which is written as 4,600. Now the midpoint between 4,500 and 4,600 would be 4,550. Now I want to locate my number on the number line. 4,528 would be about here. And so 4,528, since it is below the midpoint, would round to 4,500. If my number lies below the midpoint, it rounds down. If it lies at or above the midpoint, it rounds up. Let's round to the nearest ones place. This time I'm asking myself, how many ones make up my number? So I want to go all the way to my ones place. I have 4,528 ones. And we know that's just written as 4,528. Let's add a 1. 4,529 ones. It's just 4,529 here. In the middle of 4,528 and 4,529 is 4,528 and a half, 5/10. Now I'm going to put my number on the number line. 4,528 and 963 thousandths would be right up here. And so since my number is above the midpoint, it is going to round up. 4,529. And lastly, we are rounding to the nearest tenths place. So how many tenths? All the tenths in my number. 4,500, let me rewrite that there. I have 45,289 tenths. In standard form, that is written as 4,528 and 9 tenths. If I add a tenth here, I would have 45,290 tenths. And in standard form, that is written as 4,529 and 0 tenths. The midpoint is 4,529, 4,528 and 95 hundredths. Okay, there's my magic 5 here between my two numbers. So now I'm going to locate my number on my number line, and I see that my number falls about here. And since that's above the midpoint, it is going to round up. So my number rounds to 4,529 and 0 tenths.